So we start this experiment. First, we change the length of the pendulum, that is 40, and we take it at 20 degrees, the amplitude, and set the pendulum in motion. What am I going to do over here is I'm going to consider the oscillations. So this is one reference line for me, and this is the other reference line. So when the pendulum reaches over here, I will start the clock. So the pendulum goes there, comes back. That will be one oscillations. And we are going to measure time for 10 such oscillations. So I will let it oscillate. And when I set my eye, I will press this button over here that will start the stopwatch. So here I allow the pendulum to oscillate, and now I will start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it has taken 12.70 seconds. Now you have to repeat the same step for 2 more times. So for one length, you are taking 3 readings. Okay, in each reading, you are taking the time interval for 10 oscillations. So I continue by saying that the length is 40 centimeter and the time taken is 12.70. And therefore the time period, that will be the time taken for one oscillation, that will be divided by 10. So 1.27. Now I will change the length of the pendulum to 50. And again, I can take the same thing. I will take 20 here, 20 degrees as a amplitude. And I will again mark my reference. Now, if you don't have, you can, these guided lines will still be there on these lines for your reference. So I will reset the stopwatch. Here you can see that it is getting reset. And I will start the oscillations and I will begin now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is time taken for 10 oscillations. So here I will write again. So this is the length and this is the time and the time period. So the length was 40 and it is 12.70. So it was 1.27 and the length is 50 and it is 14.22. So it is 1.42. I'll take it up to 2 decimal places. Now the same thing we will repeat for 60 meters now. Okay, so 60 meters, I will reset the clock and then I will start the oscillations. So it begins now. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So you have to keep the mouse cursor on this and look at the mark. Okay, so what reading have we got? We have got for 60, this is 15.69, and this will be 1.57, you can say. Now the same thing you have to repeat. Now, of course, you are doing this for 3 times, T1, T2, and T3, and you're arriving at T by taking the average. Okay, so I'm showing you once, but you have to do it 3 times so that reduces the error. And you have to continue to do it for 70, 80, 90, and 100 centimeters. Okay, so I will pause the video. Once we are done with the readings, then we will see how to plot the graph. So I have done these calculations, and now what we have got is 1, 2, 3, 4, 5, 6, 7 readings. You may get similar answers. It may not be very accurate, but uh, it should be accurate up to at least one decimal place. Okay, it should match with at least with one decimal place. The second decimal can be a problem depending upon the readings that you take. So you have to take it 3 times for each length, and then you have to take an average and take the time for one oscillation. So T is calculated by this dividing by 10. So you get time for one oscillation. Now what we have to do is to plot a graph. Now before that, now this is a simulation. You can actually make a pendulum. Like suppose if you have a thread, and to that thread you can tie something heavy, a small metal ball if you have, ideally. Okay, so that will give you a pendulum, and you can tie it to some place where this will be rigid. This should not move, this part. And of course you tend to you have to take measurements then with the help of a scale that you have, and this should be the length from the center of this mass till the point where you have suspended. So you will not need a simulation, and you can use the stopwatch in your mobile phone to measure the time period. So you can perform this experiment actually by hanging something and making a simple pendulum. And again, then you don't need to restrict. Like here, the simulation doesn't allow me to take lengths more than 1 meter. There you can go beyond 1 meter. You can go up to like 150 centimeters and take the reading. So you will have more readings to plot on the graph. So now we will see how to plot it on the graph. So before we move to the graph paper, let me give you a small advice, like what should we doing. Now here on the graph paper, we are plotting length on the x-axis, and on the y-axis, we are plotting the square of time period. So what you need to have first is the square of all the values of t. Okay, so let's just check what are those values. So now what we have is t square, and we have L. So L is pretty easy. Here you can start with, suppose if you give a kink to the graph, and you can start with 40, 50, 60, 70, 80, 90, and 100. The purpose of writing this kink is that if you start from 0, then you need 10, 20, 30, and then you start with 40 onwards. So you may not be able to fit in all the values. So what you do is you kind of shrink the scale and you start directly with 40, what you want to plot, the least value. And over here also, the whole of y-axis, the smallest value is 1.61 and the maximum value is 4.04. So if you consider this as 4.10 and 1.61, then you have values like that will give you the range of value that you need to plot, and that comes to around 2.49. So that means this whole length has to be divided into 3 parts. Okay, so starting from, so suppose here also you put a king and you start from say 1.5. So 1.5, and you can go up to around say 4.2. So we will see how best can we do that. Okay, so remember one thing, the basic idea is that you have to see on your x-axis, you have to plot values from 40 to 100. So those need to be fit in that. And for the y-axis, you have values from 1.61 to 4.04. So that needs to fit in properly. So let's see how do we go about that.